So let's start with this simple metro area network example. So in this example, you can see we have 4 buildings labeled 1 through 4, and in each of these buildings will constitute a quantum network node. And this means that each of these buildings will contain stationary qubits, which will be able to store quantum information and also transmit quantum information over the network. We also have a quantum repeater in this example. This is indicated by the gold symbol within the gold circle. So the red and gold lines that connect the buildings and the quantum repeater, these lines represent fiber connections. And these fiber connections include a real-time classical channel, a non-real-time classical channel, and a quantum channel. We'll be focusing on the quantum channel in this talk today, but if you're interested to learn more about these other channels, which are really important for quantum networking, you should definitely check out another talk previously given in our webinar series by Bruno, also from Aliro. So in this example, these red connections are under 100 kilometers, and the gold connection with the repeater is over 100 kilometers. So what this repeater will do for our quantum network is it will provide a way to still allow quantum information to be transmitted with relatively low loss, even over this longer connection. In a sense, this acts as a relay station, but in a very different way than you might think of in a classical context. The types of repeaters can be kind of broadly classified into 2 different types. There are type 1 repeaters or meet-in-the-middle repeaters. These types of repeaters will use a beam splitter to generate entanglement. So you would have 2 quantum nodes containing stationary qubits. The qubits will emit photons, and the photons will combine at a beam splitter with two photodetectors. And based on the results of the photodetectors, these photons will be measured, and then it's possible to generate entanglement between the stationary qubits. So let's return to our example a bit and look back at our node at building 1 and our repeater. Now we've determined that this repeater is a type 1 repeater. So the way that entanglement will be generated between a quantum memory at node 1 and the repeater, and the quantum memory at the repeater is these quantum memories and stationary qubits will emit photons that are entangled with their corresponding stationary qubits. They will go through these transducers, and then they will combine at this beam splitter with 2 photodetectors in order to generate entanglement.